Hey folks, today we're going to learn about chemical changes. There are 4 major questions that you should be able to answer by the end of this video. 1 is, what is a chemical change? 2 is, how do you use particle diagrams to represent a chemical change? The 3rd question is, how do you use a chemical equation to represent a chemical change? And finally, how do you know that a chemical change has occurred? So, just what is a chemical change? Well, chemical changes are nothing more than a rearrangement of atoms in molecules. Unlike a mixture, which can be separated through physical means, the only way we can separate the individual elements of a compound from each other is through a chemical change. We never make anything new in a chemical change. We just take what we have, break the bonds of the atoms, move them around, and then form new bonds that make different molecules. It's very useful to represent chemical changes with a particle diagram because it can help you to visualize the atoms and how they get arranged. To do this, you just draw the atoms of the molecules that you started with before the reaction occurs. Then you draw the atoms separated out from each other with no chemical bonds between them. Finally, you draw those molecules that you end up with after you rearrange the atoms and form new bonds. It's very important to count how many atoms you started with because you're supposed to end up with the same amount of atoms when you're all finished. So here we have some molecular elements that we're going to react together. Right now you can see that we have a hydrogen molecule that consists of 2 atoms of hydrogen that are stuck together, and we have a chlorine molecule that consists of 2 atoms of chlorine stuck together. Notice how the individual atoms have broken apart from their own molecule, and now we just have 4 atoms hanging out together all by themselves without being stuck together to anything. This gives the unique opportunity for them to hook up with another atom that they haven't been with before. So let's see what's going to happen. Oh look, it looks like one of these hydrogen atoms really likes this chlorine atom, and they're starting to get closer and closer together, and you see that there's a bond that forms between them. That made a new molecular compound that we call hydrogen chloride or hydrochloric acid. It looks like the remaining hydrogen chlorine atoms are doing the same thing. Now we started out with 1 molecule of hydrogen and 1 molecule of chlorine, and we ended up with 2 molecules of hydrogen chloride. To represent a chemical change with a chemical equation, we first must know what a chemical equation looks like. So we already know that chemical symbols represent an element, but did you know that chemical formulas represent molecules? And chemical equations represent chemical reactions. So when you look at a chemical equation, it tells you what you have before a reaction occurs, and it tells you what you have after the reaction happened. So on the left side of the arrow, we have the before, or the reactants. We call these reactants because they're what we're going to react together. On the right side of the arrow, we have the after, or the products. These are called products because they're what get produced in a chemical reaction. When we're writing a chemical equation, there's a lot of information that we can take away. Each molecular formula has different chemical symbols that get smushed together, and these tell you what elements are in each molecule. You might notice that sometimes we have a little number at the bottom. We call that number a subscript. These subscripts tell you how many atoms of each of those elements we have in that particular molecule. Those subscripts go with the element that is immediately to its left. So if you see maybe H2O, that 2 goes with the H. If there's not a subscript next to an element in a molecular formula, then you assume that there is 1 atom. You also might notice that there's a really big number sometimes in front of a molecular formula, and that is what we call a coefficient. These tell us how many of those molecules we have. So if we see something that says 2H2O, that means there are 2 molecules of H2O. There's a number of ways we can decide whether chemical changes happened or not. So let's use that last chemical equation as an example. We start with 2 molecules of H2 and 1 molecule of O2. And it looks like we're going to end up with 2 molecules of H2O when we're finished. So let's go ahead and draw our reactants. So again, you see we have 2 molecules of H2 and 1 molecule of O2. If we're counting atoms, you can see we have 1, 2, 3, 4 atoms of hydrogen and 2 atoms of oxygen. So if we draw that in the middle, once all of the molecules separate into their separate elements, we can see all of those atoms just moving around. So now we have our before, we have our during reaction, and now we need to draw the after. Okay, so this is what 2 molecules of H2O looks like. We know that we have 2 molecules because there's a coefficient before the H2O. We know that in each molecule we have 2 hydrogens because that's what the subscript says, and we have 1 oxygen because it doesn't have a subscript. Now if we count, we should end up with 4 hydrogen atoms before, during, and after, and 2 oxygen atoms before, during, and after. There's a couple ways you can do these particle diagrams. I like to use different colors when I draw them, but you could just do circles with letters in them. As long as you can draw these particle diagrams and they correspond with a chemical equation, and you know which atoms are which when you draw them, you'll be fine. The only way to be 100% sure that a chemical change has happened is if you test the chemical before and after the supposed reaction happened. And if you see that you ended up with something different, then you know that a chemical reaction happened. However, we don't usually have access to that kind of chemical analysis. So we use some indicators that are usually pretty good at telling us whether a chemical change happened or not. However, when a chemical change does occur, usually one or more of the following indicators also happens. So we might see that a gas gets produced, or we see bubbles, or sometimes even it just produces a funny smell or odor. We also might see that there's a distinct color change. This color change could happen at any time in the reaction, but as long as you see a change in color, it's usually a pretty good indicator that the chemicals changed. Anytime a precipitate or a solid is formed, so you mix maybe 2 clear liquids together and a yellow solid falls to the bottom, that is an indicator that a chemical change happened. And of course, anytime there's a temperature change, anytime we either absorb or release energy and changes the temperature, that's a good indicator that a chemical change has occurred.